Before you watch the video, subscribe it, click on the bell icon for more notifications. Hi everybody, welcome to Agaamath. This is Rakesh. In the previous video, we have learnt about the division algorithm of polynomials. So children, those who do not watch it, please watch it so that this video will help you in better understanding, right? Come on. Now, how to find the other zeros of a cubic and biquadratic polynomials? Generally, if it is a quadratic polynomial, finding the zeros means we have different methods, like one of them is a factorization method. Using the factorization, we can find the zeros of a quadratic. But how to find the zeros of the cubic and biquadratic polynomials? Here, this is what we are going to learn in this video. So before that, I would like to give some example about the zeros. Is nothing that before understanding about the zeros of a cubic and biquadratic, you should be able to understand factors. Okay, so let me come with some examples now, taking with integers. Okay, so that it will help you more. Okay, now I would like to take any two integers, like performing a division and showing what are the factors first of all. Okay, so if I take that is 24 is divided by 3, so it is nothing but 3 8s 24, and we got the remainder 0. So what does it mean? If you get the remainder 0 when you do the division, it means where these two are, like divisor as well as a quotient, are said to be the factors of 24 because you got the remainder 0, right? As we got the remainder 0, we have to understand that even divisor as well as a quotient are said to be the factors. That is one observation you have to know. And one more observation let me take. Instead of taking this example, I would like to take one more example. It is like 36 divided by if I take 2. So what? How do we do? Is 2 1s 2, that is 1 and 6, 2 8s 16, right? And we got the remainder 0. So we can say that 2 and 18 are the factors of 36 because the remainder is 0. And also one more observation here we have to know, that even the factors of 18, if you take the factors of 18, that is 3, 6, 9 and 18, means even these all are also factors of 36 or not? Yes, they are the factors of 36 because it is nothing but 3 12, 6 times, 9 4 times and 18 2 times. It means what? 18 2s, 9 4, 6 6, 3 12s. Here you have to understand, when we get the remainder 0, the divisor and the quotient are said to be the factors, and also the factors of the factor is also factors of the given number. So it means very simple, the factors of 18 is also factors of 36. So these two examples will help you in finding the zeros of cubic and biquadratic polynomials. Now let us go with the question. Now here I would like to take a question. Here my question is, if 2 is a 0 of a cubic polynomial, f of x equals to x cube minus 7x square plus 16x minus 12, then find the other zeros. We know that it is a cubic polynomial whose degree is 3, right? So that we get 3 zeros, but already 1 0 is given. Now we have to find the other 2 zeros. Okay, so what we do is, here we already know that 2 is a 0 of the cubic polynomial that is given, means it means nothing that x is equals to 2, right? If x is equals to 2, because in the place of x, if we substitute, that becomes 0. So if x is equals to 2 is a 0 of the polynomial, 0 of the polynomial, then x minus 2 is a factor of the given polynomial, right? X minus 2 is a factor. This already we have learned in the 9th class. So based on that, now x minus 2 is a factor. For this factor means we know if we do a division, we should get the remainder 0. Chalo, let us see now. So that is x minus 2, and this is x cube minus 7x square plus 16x minus 12. Now let us perform a division. X, how many times? X square times, so that you get x cube. Minus 2 into x square is minus 2x square, and this becomes minus and this becomes plus, so that is eliminated. Minus 7x square plus 2x square is minus 5x square plus 16x minus 12, right? So now x how many times? Minus 5x times, so we get minus 5x square. Minus 2 into minus 5x, that is plus 10x. And now if I do the same again, this becomes plus and this becomes minus. Eliminated. 16x minus 10x is 6x minus 12. Now x is how many times? 6 times, plus 6 times, that is 6x. Minus 2 into 6 is minus 12. Now if you do that, this becomes minus and this becomes plus, so both got eliminated, remainder 0. And before, even with integers, when we perform a division, there we knew if the remainder is 0, so that even divisor as well as a quotient are said to be the factors. And also the factors of the quotient is also the factors of this dividend, right? Similarly, now what we do is we just find the factors of this. So what I do is I would like to find the factors of x square minus 5x plus 6. So let us do the splitting method. In the previous videos even we learned how to factorize. So that is x square minus 3x minus 2x plus 6. So in both of these x is common, so x minus 3, here minus 2 is common, so x minus 3, right? So now x minus 3 is common in the both. If I take x minus 3 as a common, so x minus 2 is left. So these are the factors, right? But we have to find the zeros. So very simple. Let x minus 3 of x minus 2 equals to 0. It means x minus 3 equal to 0 or x minus 2 equals to 0. It's nothing that x equals to 3 or x equals to 2. So what are the other two zeros? 3 and 2 are the other two zeros. Very simple. Whenever one 0 is given, so that is x equal to 2 is 0 of the polynomial, then x minus 2 is a factor. So just perform a division. After performing division, as we get the remainder 0, we know that this divisor as well as a quotient are said to be the factors. Now we will find the factors of this and make them as equal to 0 to find the zeros, so that we get the zeros there. So those two. So what are the other two zeros means? So total the given is 2, and again we have 3 and 2 are the zeros. So 3 and 2 are the zeros of this cubic polynomial, other two zeros. So this is a way how to find the zeros of a cubic polynomial. Now we will see how to find the zeros of a biquadratic polynomial, right? Let us see now. Now here I would like to take another question which is related with the biquadratic polynomial. So find all the zeros. Find all the zeros. Find all the zeros of the polynomial. Find all the zeros of the polynomial f of x. F of x equals to 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5. Find all the zeros of the polynomial f of x equals to 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5. If two of its zeros are under root 5 by 3 and minus under root 5 by 3. So how to find all the other zeros, all the zeros of the polynomial when two zeros are given? Let us see now. So we know that this is a biquadratic polynomial whose degree is 4, so that we have to get the 4 zeros. So of them, 2 zeros are already given. So we know that x, if x is equals to under root 5 by 3 and x equals to minus under root 5 by 3 are the zeros, then x minus under root 5 by 3 of x minus under root 5 by, this is plus x plus under root 5 by 3 are the factors. Right? Or the factors of what? Or the factors of this given polynomial f of x. So that are the factors of f of x. So what I do is, as they are the factors, right? So I just have a product of these two, that is x minus under root 5 by 3 of x minus x plus under root 5 by 3 equals to, what we get is x square minus 5 by 3 whole square, because a minus b of a plus b. So what do we get? We get x square minus 5 by 3. So this is a factor of this what given f of x. So what I do is I perform a division now, right? Even this in a simplified as 3 is where 3 is a constant, it means it can be written as 3x square minus 5. So now I would like to perform a division with this factor, right? So what here the f of x is what? 3x to the power 4 plus 6x cube minus 21x, right? Minus 2x square minus 10x minus 5, right? So here I write 3x square minus 5. This is a divisor, and the f of x is nothing but what? 3x to the power 4, right? Plus 6x cube minus 2x square minus 10x minus 5. 5. Now let us perform a division. 3 that is x square times, right? X square times, that is 3x to the power 4 minus 5 into x square is minus 5x square. So that this is minus and this becomes plus. So eliminated. The next is 6x cube plus 3x square minus 10x minus 5. Now 3 how many times to get 6x cube? That is plus 2x times. So that is 6x cube minus 5 into 2x is minus 10x. So that is, this is minus and this becomes plus. So both get eliminated, minus 10x plus 10x. So what is left? 3x square minus 5. So 3x square how many times? It is just plus 1 time. So that is 3x square minus 5 into 1 is minus 5. So this becomes minus and this becomes plus. So both get eliminated and the remainder is 0. So that the divisor as well as the quotient are also factors. Now we find the factors of this x square plus 2x plus 1, right? Let us do now. X square plus 2x plus 1, right? So to find x square plus x plus x plus 1. So here x is common in the both first two terms. So it is x plus 1 plus 1 is common, x plus 1. So x plus 1 of x plus 1. X plus 1 of x plus 1. To find the zeros, what we do is x plus 1 of x plus 1 equals to 0. It means x plus 1 equal to 0 or x plus 1 equal to 0. So with this we understood that x equals to minus 1 or minus 1. It means both the zeros are equal here. So what are the other zeros here? Both minus 1 and minus 1. So find all the other zeros, yeah, right? All the other zeros means already it is given that x equals to under root 5 by 2 and minus under root 5 by 2, and now we knew here minus 1 and minus 1 are the zeros of f of x, that is biquadratic polynomial. See here we got the 4 zeros. So this is a way how to find the zeros of even a cubic as well as biquadratic. Very simple. Just perform a division when you get the quotient and see that if you get the remainder 0, then these are said to be the factors. So if you find the factors of the quotient and making equal to 0 to find the zeros, so that you will get the other 2 zeros also. Fine. So this is a way how to solve. I hope you all understood well. For any more queries, just give us mail at askagaamath@gmail.com, or even you can give us a WhatsApp at 970106964. Thank you. See you. Bye bye.